Hello everyone, I'm Akash. In today's video, we will solve this interesting question on number theory which is asked in NBHM 2023 exam. Question is, we have to find all integers m satisfying this inequality and such that m square congruent to m modulo 1000. We can solve this question in two ways. First, by using basic number theory approach, and second, by using a ring theory approach. In this video, I will solve this question using both the ways. First, by using a basic number theory approach, and then by using a ring theory approach. So let's begin the solution. So let's solve this question first by using a basic number theory approach. We have given that m square congruent to m modulo 1000. So by definition of congruence modulo n, this implies 1000 divides m square minus n, because by definition of congruence modulo m, we know that a congruent to b mod n if and only if n divides a minus b. Okay, and that is 1000 divides m times m minus 1. Okay, now I can write m 1000 as 2 cube times 5 cube. So 2 cube times 5 cube divides m into m minus 1. Okay, and from this we conclude that 2 cube divides m into m minus 1 and 5 cube divides m into m minus 1. Okay, and as m and m minus 1 are consecutive integers, so from this we conclude that 2 cube divides m or 2 cube divides m minus 1. Okay, continuing this and condition, 5 cube divides m or 5 cube divides m minus 1. Okay, so we will consider the different cases. Clearly there are 4 cases, so let's consider the case first. Two cube divides m and 5 cube divides m. Okay, now a divides b implies b equals to some multiple of a. So from here we get m equals to some multiple of 5 cube, and 5 cube is 125, and multiple of 5 cube, that is 125 times n. Okay, where n is positive integer. But we have given that m must be live in this range. So m is multiple of 125 and lies in this range. So possible values of m are 125 times 2, that is 250, 375 and 500, 625, 750, 875. Okay, so these are only values of m which are multiple of 125 and lies in this range. But m also satisfies this condition, that is 8 divides m. Okay, 8 divides m. Okay, that is when you consider m modulo 8, then the remainder must be 0. 8 divides m means when you consider m modulo 8, the remainder must be equals to 0. Now clearly consider the modulos 8 of these numbers. You can verify that 125 modulo 8 not equals to 0. To see it, just divide 125 by 8. Okay, so the remainder is 5. So from here we see that 125 modulo 8 is equals to 5, not equals to 0. Okay. So M does not satisfy this condition. That is 125 does not satisfy this condition. So 125 is discarded. Similarly, you can verify that 250 does not satisfy this condition. 375, 500, 625, 750 and 875. All of these numbers does not satisfy this condition. So in case first, we get no solution. Okay. In the case first, we get no solution. Now let's move to the case 2. So up to now, we have seen that in case 1, we get no solution. So let's consider the different case. Case 2. Say 2 cube divides m and 5 cube divides m minus 1. Okay. Now a divides b means that b is a multiple of a. So from here we get m minus 1 is a multiple of 5 cube, that is 125 times n. Okay, where n is positive integer. From here this implies m equals to 125 n plus 1. Okay, but values of m lies in this range. Okay, so m is 1 plus multiple of 125 and lies in this range. So possible values of m are 125 times 1 plus 1, that is 126. 125 times 2 plus 1, that is 251. 125 times 3 plus 1, that is 376. 125 times 4 plus 1, that is 501. Next value is 626. Next is 751 and the next is 876. Okay, and these are only values of m which satisfy this condition and lies in this range. Okay, but we have in this case 8 divides m. Okay, that is 8 divides m, that is values of m also satisfy this condition, that is m modulo 8 is equals to 0. But you can verify that for 126, when m equals to 126, 126 modulo 8 not equals to 0. To see this, just divide 126 by 8. Okay, so we get remainder 6. So this implies 126 modulo 8 is equals to 6, not equals to 0. Okay, that implies 8 does not divide 126. So this is discarded. Similarly, you can consider 251 modulo 8. Again, you will see that it is not equals to 0. So 8 does not divide 251. Okay. In case of 376 modulo 8. So let's consider this division. So remainder is 0. So from here we get 376 modulo 8 equals to 0. That is 8 divides 376. Okay, that is this condition is satisfied. So one possible value of m is 376. And you can verify that for all these values m modulo 8 not equals to 0. Okay, that is when you consider 501 modulo 8, then it is not equals to 0. 626 modulo 8 not equals to 0, and so on. That is 8 does not divide 501, 8 does not divide 626, 8 does not divide 751, 8 does not divide 876. So in this case, case 2, we get only one solution and that is m equals to 376. Now let's move to the next case. So up to now we have seen these two cases. In the case first we get no solution. In the case second we get one solution, which is m equals to 376. Now let's move to the next case, case 3. Say 2 cube divides m minus 1 and 5 cube divides m. Okay. Again, a divides b means that b is a multiple of a. That is, m is a multiple of 5 cube. That is 125n. Okay. Multiple of 5 cube, where n is some positive integer. But values of m lies in this range. So possible values of m are just multiple of 125, which are less than 999. 125, 250, 375, 500, 625, 750, 875. Okay. So these are only values which are multiple of 125 and which are less than 999 and greater than 2. But from this condition, we have a divides b, that means b is a multiple of a. So m minus 1 is a multiple of 2 cube, that is 8k, where k is some positive integer. And that implies m must be of form 1 plus 8k. Okay. So this means that when you consider m modulo 8, you get this will become 0 and the remainder will be 1. Okay. So m modulo 8 result in 1. Okay. But you can verify that 125 modulo 8 is not equals to 1. To see it, just divide 125 by 8. Okay. So the remainder is 5. So from here we see that 125 modulo 8 is equals to 5, not equals to 1. So 125 is discarded. Similarly, 250 modulo 8 is not equals to 1. So m does not satisfy this condition. So 250 is discarded. Now let's verify for 375. 375 when divided by 8 gives remainder 7, which is not equals to 1. So m modulo, that is 375 modulo 8 is equals to 7, not equals to 1. So 375 does not satisfy this condition. So this is also discarded. Similarly, you can verify that 500 is also discarded. Now let's verify for 625. Now when you divide 625 by 8, you get remainder 1. Okay. You get remainder 1. So 625 modulo 8 is 1. Okay. Answer is remainder. Okay. So 625 modulo 8 is equals to 1. That implies 625 satisfy this condition and this condition also. So one possible value for m is 625. And you can verify that 725 does not satisfy this condition and 875 also does not satisfy this condition. So in this case, we get only one solution, and which is m equals to 625. Now let's move to the next case. So up to now we have seen these three cases. In the case first, we get no solution. In case 2, we get m equals to 376, only solution. And in case 3, again we get only one solution, which is m equals to 625. Now let's move to the last case, which is case 4. 2 cube divides m minus 1 and 2 cube divides m minus 1 and 5 cube divides m minus 1. This is the only case which remains. Okay. Now, again, a divides b, that means b is a multiple of a. So m minus 1 is a multiple of 5 cube, that is 125. So 125 times n. So from here we get m equals to 125n plus 1. But values of m lies in this range. So possible values for m are 125 times 1 plus 1, that is 126. 125 times 2 plus 1, that is 251. We are adding 1 to those previous values, that is multiple of 125. Okay, 376, 501, 626, 751 and 876. So these are only values of m which is equals to 1 plus multiple of 125 and which lies between this range. Okay, but m also satisfies this condition. Okay, because there is an and. Okay, so m also satisfies this condition. So this condition, a divides b, so b is a multiple of a. So m minus 1 is a multiple of 8, that is 8k. So this implies m is of form 1 plus 8k. Okay, and that implies when you consider m modulo 8, so the remainder will be 1. Okay, when you consider m modulo 8, this will become 0 and the remainder is 1. So you have to verify which of these values satisfy this condition. Just consider modulo 8 and check whether it is equals to 1 or not. For example, in case of 126, when you divide 126 by 8, you get remainder 6. So 126 modulo 8 is equals to this remainder, that is 6, not equals to 1. So 126 does not satisfy this condition, that means 126 does not satisfy this condition. Okay, so 126 is discarded. Similarly, you can verify that 251 also does not satisfy this condition. Okay, so it is also discarded. Let's verify for 376. Okay, 376 modulo 8. So just divide 8 by 376. So just divide 376 by 8. So it is equals to 0, not equals to 1. So again, in this case, 376 is also not a solution. So you can verify that all of these are not solution. So in this case, we get no solution. Okay. So this case gives no solution. Okay. So only solution of this are m equals to 376 and m equals to 625, which occurs in case 2 and case 3. Okay, so the integers which lies in this range and satisfy this condition, that is m square congruent to m modulo 1000, are m equals to 376 and m equals to 625. So those students who are not comfortable in a ring theory approach, they can solve this question in this way, that is by using basic number theory approach. Now let's solve this same question by using a ring theory approach. Now let's solve this question by using a ring theory approach. In particular, we will use Chinese remainder theorem, which is one of the most famous results in ring theory in abstract algebra. Chinese remainder theorem can be stated as the mapping m mod n maps to m mod n1 up to so on m mod Nk is a ring isomorphism, okay, where this integer n is positive integer and can be written as product of prime powers n1, n2 and so on nk, okay, product, okay. So these ni's are prime powers and these ni's, that is GCD of ni comma nj is equals to 1 for every I comma j varying from 1 to k, okay. That is, this n is a product of prime powers and these prime powers n1, n2 and so on nk are relatively prime also, okay. So by Chinese remainder theorem, this mapping is a ring isomorphism. Let's denote this mapping by phi. So by Chinese remainder theorem, we have the ring Z by Nz is isomorphic to direct product of ring. This is an element of direct product of ring, and which is nothing but Z by N1z and so on, Z by Nkz, okay. We know that this is nothing but the ring Zn, okay. So the ring Zn is isomorphic to the direct product of the ring Zn1 up to so on ring Znk, okay. We will use one more result. Let's write that first. An element x comma y, ordered pair x comma y, belongs to the direct product of the ring R1 comma R2. This element belongs to this direct product of the ring is an idempotent if and only if x is idempotent in R1 and y is idempotent in R2, okay. This element in this direct product of ring is an idempotent if and only if this first coordinate is an idempotent in this first ring and this second coordinate is idempotent in this second ring. Why we have considered idempotent element? Because this condition is equivalent to saying that M is idempotent element in ring Z1000, okay. What are idempotent elements? The element x belongs to some ring is said to be idempotent if x square equals to x, okay. So here we see that m square equals to m, okay, and we are in ring Z1000. That's why we have considered modulo 1000. So m square equals to m in Z1000. That means that m is an idempotent element in ring Z1000, okay. So basically we have to find out the idempotent element in this ring. So we will use this Chinese remainder theorem and this result. Now I can write this Z1000 as this, okay. And since by Chinese remainder theorem this ring is isomorphic to the direct product of the rings Z by 8z times Z by 125z, okay, because 8 and 125 are prime powers and they are relatively prime and their product is 1000, okay. So this is by Chinese remainder theorem. Now we will use the fact that these two rings are local rings, that is they have unique maximal ideal, okay. These two rings are local rings and hence only idempotent element in these rings are 0 and 1, because in local ring only idempotent elements are 0 and 1. So this ring has only two idempotent elements, which is 0 mod 8 and 1 mod 8, and this ring has only two idempotent elements, which is 0 mod 125 and 1 mod 125. Okay. Now let's define this map for this ring. Okay. So this mapping is like five maps M mod 1000 to order pair M mod 8 and M mod 125. Okay. Now, as I have stated here that these two are local rings, so their idempotent elements are 0 and 1 only. So by this result, ordered pair belongs to this direct product is an idempotent if and only if its first coordinate is idempotent in first ring and its second coordinate is idempotent in second ring. So only possible idempotent element in this direct product of rings are 0, 0, 1, 1, 1, 0 and 0, 1. Okay. Because 0 and 1 are only idempotent element in this ring and 0 and 1 are only idempotent element in this ring because they are local rings. So only possibilities for idempotent in this direct product are these four. Okay. And as this mapping phi is a ring isomorphism, so it is a ring homomorphism. So from here, the pre-image of 0, this 0 element in this direct product is nothing but 0 element in this ring, and pre-image of this is nothing but unity in this ring. And so just we have to find the pre-images of these two. Okay. And clearly we cannot consider these two 0 and 1 because the M range in 2 less or equals to M less or equals to 999. So we have to find out the non-trivial idempotents in this Z1000. So we have to find out the pre-images of these two. Okay. Now let's find out the pre-image of this. Okay. Mapping is this. So I am writing for this case. So here M mod 1000 maps to M mod 8 and M mod 125, and this result is equals to 1, 0. Okay. Now this mapping is phi. Okay. So from here this implies M mod 8 equals to 1, that means M congruent to, this is nothing but 1 modulo 8 and this is nothing but 0 mod 125 because we are in this direct product. Okay. So M mod 8 equals to M 1 mod 8, that implies M congruent to 1 mod 8. Okay. And here M mod 125 equals to 0 mod 125, that implies M congruent to 0 mod 125. Okay. And from here we get 125 divides M, that is M is a multiple of 125. So M is a multiple of 125 and we have seen the multiple of 125s and the range of M is this. So possible values for M is 125, 250, 375, 500, 625, 750 and 876. These are only possible values for M. Okay, because M lies in this range. And from this condition we have, when we consider M mod 8, the remainder must be 1. Okay. So consider modulo 8 of these numbers. For example, when we consider modulo 8 of 125, that is just divide 125 by 8 and find out the remainder. So 1, 8, 45, 40, so the remainder is 5. So 125 modulo 8 is nothing but 5, not equals to 1. So 125 modulo 8 is not equals to 1. So this implies 125 does not satisfy this condition. So 125 is discarded. Similarly, you can verify that 250 does not satisfy this condition. Let's verify for 375. 375 modulo 8. So we have to divide 375 by 8. Okay. So the remainder is 6. So 375 modulo 8 is 6, not equals to 1. So 375 is also does not satisfy this condition. And this is also does not satisfy this condition, this and this too. Now let's verify for 625. 625 modulo 8. Divide 625 by 8. So we get the remainder is 1. So 625 satisfy this condition. 625 modulo 8 is 1 because remainder is 1. So 625 satisfy this condition. So one possible value for this is m equals to 625. So in this case, the pre-image is 625. Now let's consider this case. Now what is remain is to find the pre-image of this element 0, 1 in this one. We have to find its pre-image. So again, what is the mapping? Phi maps m modulo 1000 to m modulo 8 m modulo 125, and the output result is 0, 1. This is nothing but 0 modulo 8, 1 modulo 125, because this is an element of this ring. Okay. So from here, we have m modulo 8 equals to 0 modulo 8. That means m congruent to 0 mod 8. Okay. And m modulo 125 equals to 1 modulo 125. That means m congruent to 1 mod 125. Okay. So from here we have 125 divides m minus 1. Okay. So m minus 1 is a multiple of 125. That implies m minus 1 is equals to 125n. Okay, where n is some positive integer, and that implies m equals to 1 plus 125n. Okay. So m is nothing but multiple of 125 added with 1, and a range of m lies in this. Okay. So possible values of m are, we have seen earlier too, 126, 251, 376, 501, 626, 751 and 876. These are only possible values of m which satisfy this and which lies in this range. But m also satisfies this condition, and this is nothing but when you consider modulo 8 of m, you get the remainder 0. Okay. So you can clearly verify that 126 modulo 8 is not equals to 0. So this is discarded. This is also discarded. Okay. And this is also discarded. This is also discarded. For example, consider 626 modulo 8. Okay. Just divide it by it. So the remainder is 2. So 626 modulo 8 is equals to 2, not equals to 0. So 626 does not satisfy this condition. Okay. So it is discarded. It is also discarded. It is also discarded. And you can easily verify that 376 modulo 8 is equals to 0. That is 8 divide 376. Okay. So 376 satisfy this condition. So the pre-image of this element is 376. Okay. So the values of m which satisfy this condition, that is m square congruent to m modulo 1000, and which lies in this range, that is idempotent element in this ring, non-trivial idempotent element in this ring Z1000 are 376 and 625. Okay, so we have solved this question in two ways. First, by basic number theory approach, and second by ring theory approach. So if you found this video interesting and helpful, then please like and share this video and subscribe to our YouTube channel. Thank you for watching.